A megasatellite orbiting Ceres would make a fine home for humans. It is unlikely that humanity will ever see our way outside the solar system to colonize exoplanets, but the possibility of settling elsewhere inside the solar system is not so far-fetched. NASA is planning an outpost on the moon. Crewed missions to Mars aren't far off. We even already have humans living off planet on the International Space System. So, is there anywhere else in the solar system that human could make our home? Well, according to the physicist Pekka Janhunen of Finnish Meteorological Institute of Finland, dwarf planet Ceres is not entirely implausible. Ceres is an interesting chunk of rock. It hangs out in the asteroid belt between Mars and Jupiter. It is considered both the largest known asteroid in the solar system and the only dwarf planet closer to the Sun than Neptune. An alternate to the planetary colony model is an artificial space colony orbiting the Sun, a space station spinning to generate enough centrifugal force to mimic one, for example, Earth's gravity. This would be logistically awful too. If the population grows too large for one settlement, multiple settlements may be required. If multiple colonies are in orbit around the Sun, they could drift apart, creating other problems such as inter-settlement travel. If they are orbiting a common body, collision avoidance becomes a problem. So the physicist solution is quite neat, really, at least in concept. Use Ceres as a base around which the spinning settlement nodes could orbit, connected by a fixed frame. We also know that Ceres is pretty salty, and recent research suggests that it also might have a lot of water below the surface. Solar panels on the dwarf planet's surface could easily power a space elevator to the satellite. Lifting the materials from Ceres is energetically cheap compared to processing them into habitats. If a space elevator is used, the Ceres has low gravity and rotates relatively fast. The space elevator is feasible. Because Ceres is so far from the Sun, mirrors could also be used to direct sunlight towards the habitat for the purpose of growing crops, for illumination, and for solar power. These mirrors would be hinged on one side of the disc-shaped satellite like a makeup compact, and could be adjusted to collect the most sunlight as the dwarf planet moves around the Sun. The habitats are illuminated by natural sunlight. The overall level of difficulty of executing this project is probably similar to settling in Mars. This has been said by the scientist Janhunen, who calculates it around the Ceres would take around 22 years to build a human satellite in orbit around Ceres. It requires some effort to lift the materials to orbit using the elevator, but it is energetically cheap. Once the materials are in high Ceres orbit, the thermal environment is uniform and energy is easy to get due to the absence of eclipses.